Okay, so this is the data response question, question 23. One of the most important things to do in a data response question is make sure you really read the section at the top. So antiretroviral drugs are used to treat HIV virus infections. Zidovudine and nevirapine are examples of antiretroviral drugs. There are concerns that these drugs may be toxic to body cells in mitosis. In a studying using allium cepa root tips were exposed to the drugs for 96 hours at a range of concentrations. The control treatment was a drug concentration of 0 micromoles. In the graph, the root lengths after a 96-hour treatment period are expressed as a percentage of the control. Okay, so the first thing we need to do is work out what this graph is showing. So here we've got the root length as a percentage of the control, and here we've got the drug concentration. So immediately what you can see is as you increase the concentration, you decrease the root length, and it's kind of like this first bit is really seems to be pretty critical. Okay, so question 23a, deduce the concentration of ZDV that would cause a 50% reduction in the root growth compared to the control. So the first thing to do is which line is ZDV, so that's the grey diamonds, okay, and so then what you do is you find 50% here, and obviously you would do this with a ruler and track across to there and then track down to there, okay, and then read off the graph. Now if you do this properly with a ruler, you should get to 75, and then you've got to remember to include the unit, which is micromoles. Okay, now the range, the acceptable range for this was 70 to 80. Okay, so then 23b, identify the root length as a percentage of the control resulting from a ZDV concentration of 400 micromoles. Okay, this time we go back here and we look at the drug concentration here, so 400, so you'd rule up there, and then you'd rule across from the center of that point, okay, across to there. Again, you would use a ruler and do it properly, and the answer was 24, and this time the unit is percent, and the acceptable range was 23 to 25. Okay, so 23c, compare and contrast the effect of ZDV and NVP on allium roots. Now remember, compare and contrast is similarities and differences. Okay, so that's what the command word is telling us to do, and the number of marks is 2. So we want to have two things, one similarity and one difference. Okay, so we're having a look here, so let's look at similarities. So similarities is that both of them would reduce the root length compared to the control. You could also say that both ZVV and NVP have the greatest change in growth at the lowest concentration, so in this yellow section of the graph. At this point here, they seem to have the same effect, and they both level off at this point here, okay, at 400 micromoles. So those could be your similarities. In terms of your differences, you could say that after this point here, they diverge, so you see the greatest difference in the effect. You could say that ZDV, this line, has the larger effect than the NVP. Okay, so those are the sorts of things that you're trying to say for your similarities and differences, one of each. Okay, so now we move on, and it says both ZDV and NVP are believed to have a damaging effect on the process of mitosis, but ZDV in particular is believed to block the formation of the spindle. So based on the information, suggest which of the labelled cell types will become more common in allium root tips treated with ZDV. Well, if you think about it, if ZDV stops the formation of the spindle, then that's going to mean that cell types that don't have spindle formation, i.e. mitosis, becomes less common. So X is showing a cell in anaphase, and here you can still see the spindle. Z is showing a cell in telophase. Well, to get to there, it would have needed the spindle here. Y, however, is showing a cell in interphase. So the answer is, first of all, Y will become more common, okay, but we've got 2 marks. So we need a reason as well, okay. So you could talk about the fact that interphase doesn't have spindles, that in X and Z there are spindles, and that cells in Y cannot progress into cells in mitosis because there is no formation of a spindle fibre. Okay, so 23E, allium root tips continue to show some growth even at high concentrations of NVP, suggest a possible reason for the growth seen in the root tips of 800 micromoles of NVP. Okay, so there are a number of things you could say here. You could say that some cells, there's still going to be some mitosis. Okay, it doesn't say it prevents all spindle formation. Some cells will get bigger just through the absorption of water. So root tips might grow a little bit just because of the absorption of water. And a reminder that NVP isn't 100% effective, so it's not going to enter all of the cells, so therefore not all of them will be prevented from undergoing mitosis. Okay, so now the next graph. Mitosis plays an important role in tissue regeneration and can be an important factor in recovery from surgery. The hormone leptin has been shown to promote mitosis in certain circumstances. The bar chart shows mitotic indices of liver tissue exposed to leptin and control tissue during 72 hours after surgery. Okay, so if you look at this, you can see a higher mitotic index will indicate more cell division. And in all of these, leptin is giving a higher mitotic index. So the control group, the dark bars, they remain basically the same, whereas the leptin ones increase over time. So 23F says, deduce the change in mitotic index after 72 hours compared to the control. Okay, so to do this, you're going to need to establish what is this level. Okay, so this level is about 0.6. What is this level? This level is about 0.3. Okay, so there are a number of different ways you could say this. So you could say that it's a difference of 0.3. You could say it's a 100% increase, or you could say that it has doubled. Okay. So then 23G, based on the data, evaluate the evidence for leptin promoting regeneration of liver tissue. Okay, so it's 3 marks. So you're going to be needing to make 3 points where you are evaluating evidence. So remember, evaluate, we're probably looking for strengths and weaknesses. So you could say the straightforward thing of mitotic index in the treatment group is greater than in control, so leptin appears to promote mitosis. You can say that the mitotic index increases with time, which would indicate that it's increasing growth. Or you could use the term positive correlation there between exposure to length of exposure of leptin and mitotic index. But then some kind of other side of it, some negatives, is obviously we've only seen this experiment for 72 hours, and you would probably expect regeneration to take more than 72 hours. And we have no understanding of the sample size, the error bars, the range of the data, and things like that. Okay, so just a reminder that where we have this term evaluate, we do need to see both strengths and weaknesses. And that is the data response question.